Hello, Mike. How are you? Good to see you on here. We're going to be trying a couple different things tonight, so it'll be a little interesting, but it'll be fun. How's your night going? Then we'll just, let me see here. I just got a writing tablet, and so I'm going to be trying out this writing tablet in our live stream. So you get to see my amazing handwriting. And what we're going to be covering in tonight's live stream is going to be the new blogs that I've written. I'll go through what those are, what they cover, and kind of just give my editorial on those. We'll then move into our teaching topic, and then I will move into question and answer session. I'm going to pull this over here so I can see what folks are saying. Yeah, thanks. It was fun. It was a lot of fun. I wish I could do this all the time. Unfortunately, I probably wouldn't have a marriage if I did this every night. So, but as I said, we're going to be moving through the new blogs. We're going to move through the teaching topic, and we're going to move through the question and answer. And tonight's teaching topic is going to be on the subject of not M. Like I said, I'm figuring this thing out as I go. It's going to be on the topic of networks. And we're going to go through all of the concepts of networks that we could cover in about 30 minutes. So we'll be going through some interesting topics. We'll dive through several things, and I think all of you will enjoy it. So with that being said, I am going to go here, and I'm going to just check these comments, and I'm going to open up. And are you seeing my screen? Is this all coming through good? Uh-oh. What did I do? That's a little weird. Oh. It said the stream has ended, and I was freaking out there for a second. All right. I was worried I might have killed something. Okay, so here we go. Now, the first thing I wanted to cover is I finished the How to Evaluate Building Automation series. So in this series, I went through 10 criteria that you can utilize to both evaluate building automation system proposals, but you can also use these criteria to write better proposals, to write better specifications, or simply to understand what would be expected in a quote-unquote good building automation system design and specifications. So I go through the 10 criterias, which are openness, graphics, alarming. You guys can read just as well as I can, so I won't read all these to you. And this article is about 12,000 words long, so it's a long one. I've been working on it for a while now. But you'll see as you go through this, cover kind of all these different topics, and then here, for example, under openness, I unpack what openness actually means. I talk through, there's open procurement, open protocols, open APIs, and open software. And I talk through what each one of these means, because it seems like everyone has a different understanding of what open actually means. So I go through that, and then the next thing I did was, oops, here we go. Let me open up this. Is I started what I call the Learn series. And the Learn series is going to be a weekly post every week. And I created this morning the PID loop. And I'm going to be going over PID loops over the next couple days. And essentially, in this article, I talk about what PID loops are and how do PID loops function. And the thing is, with PID loops, a lot of folks don't understand how they work. So we are going to do our first little whiteboard right here. So if I just go here and I open up my drawing pad, and I'm going to take us through what PID loops are. So I can't see how many people are watching this right now, but if you're still there, it's saying it's live. So here we go. All right, so PID loops. So in building automation systems, when you're working with any building automation system controller, you're likely to encounter a PID loop. And a PID loop, essentially, if you think about it, right, you've got your temp sensor. So that's going to be this with a T in the middle. And then you've got down here your set point, right? And let's say that your temp sensor is 70 degrees, but your set point is 72 degrees. Well, the difference between that is 2 degrees, and so a PID loop would say that that's considered error, right? There's a difference between temperature and the actual set point. Well, that 2 degree error is going to go into this control block. And this control block, called a PID loop, is going to have a proportional and an integral and a derivative, although in the building automation space we don't really use derivative. And what the proportional is, so it's proportional, so you've got this what is called KP. I'm going to put it down here. And KP is your proportional factor. So what happens is this error of 2 gets multiplied by KP. So we would say error times KP. And what we're trying to get to here, folks, is our output. Because our output is then going to go and drive our little VAV box here and our little damper actuator. So that might be damper output, right? And our output is going to drive this damper output based on this error. So over time, this error, which is now giving us an output of 4%, because let's say our KP is also 2. It equals 2. So 2 times 2 is 4. We've got 4% output. So y'all following me so far? Is this making sense? Just give me a yes or give me a slow down. And then right here what we're doing, if I can find where my little cursor went. Okay. So then we have what is called integral, right? So proportional is always going to be proportional to the KP, the proportional factor, times the error. Okay? And so then what we're getting here, and I'm just going to refresh this, see what was said real quick. Yep. Okay, cool. So we've got integral, and integral is going to be what's called the I. And you're going to have ILim and Imax. So these are going to be your settings. So your ILim is going to be how much the integral can increase each pass. And basically what's going to happen is you're going to have this time factor. So let's say we're going to use an ILim of 1.5, and we'll say that our Imax is 60. We're just going to say that. So each time your loop runs, and a loop will typically run every second. Each time your loop runs, you're going to take the sum, and I cannot for the life of me remember the mathematical symbol for sum, but we're just going to use the Excel symbol for sum. The sum of ilim, as long as ilim is not greater than Imax. And what's going to happen is this is going to equal your output. So what's happening is that as this refreshes time and time again, this loop, hold on, here we go. This loop is recycling. It just keeps recycling. And then what happens is this error right here, which we know comes from the difference between set point and temperature, that error plus or times the proportional factor plus the sum of your ilim, which we know is 1.5, and that gets 1.5 plus 1.5 plus 1.5 each time it cycles, as long as it doesn't go greater than Imax, equals output. So essentially, we could get to the point where we get 64%. And when you're tuning things, you also have one more value, which I'm going to put over here, and that's called your STUP value, or startup. And so you could say that I want it to start up at 25. That means your output is going to start off at 25%. It's always going to get 25% at least. And so when you're tuning your PID loops, you'll want to figure out what your STUP value is. You'll want to know how fast your loop reacts, and that will determine your ilim right here. And what do I mean by how fast your loop reacts? Well, if you have a chilled water plant or some sort of pressure sensor or something that, is reacting very quick due to the volume it's putting through of air or water, then you're going to want to have a fast-acting loop. But if you have something that changes very slowly, something with a wide span, then you'll want to have a slow-acting loop. Now, reverse that. I'm going on the fly on this, sorry. You're going to want to have a slow-acting loop if it's something that reacts very fast. You're going to want to have a fast-acting loop if it's something that reacts very slow. Wait, I'm confusing myself here. Let me write this down. Here we go. Okay. Pressure sensor, pressure reacts very fast. Thus, yes, I do want to have a slow-acting loop because I don't want to overshoot. Yep, I'm right. The inverse, fast is slow, and then slow is fast. So hopefully you guys are following my confusing rambling there for a second. It's late at night, and I'm using a tablet that I've never used before, so bear with me. But basically what we see is when we add the STUP value, then what we're getting here is we could potentially get 89% as our total value. Now, obviously, that's not 100%, so these numbers probably wouldn't work. All right, so what we're looking at here, I'm going to go through this one last time before I move off of this topic, and that is you've got your process variable, PV, also known as the input, also known as the input variable, and you've got your set point, SP. The difference between the two is the error. Set point minus PV equals error. Then you've got your factor for your proportional side of your loop, and that is the factor that times the error. Error times proportional factor, plus the sum of your ilim. That's the time piece. So proportional is the proportional piece. This is the integral time piece. And as you go through these loops again and again, you're going to add more to your output. But you can't add more than the Imax. And finally, you've got your STUP value over here. And your STUP value is going to be your startup value. This is especially useful in heating scenarios where you don't want to immediately go to heating, but your PID error might be so large when you kick off that you may use like a negative number. And then on cooling, you want to go to cooling right away, so you may use a positive number just to give it a little bit of a oomph right when it kicks off. I don't recommend using STUP if you don't have to, because that kind of essentially defeats the point of a tuned loop. So any questions on this? I see that right here. Let me just refresh this. Hopefully you all are following this. All right. So, with that being said, I'm going to clear off this whiteboard. Flush this out. Alrighty. So, the topic everyone's been waiting for. The network topic. Now, I'm going to ask the folks in the audience if you could just take a second and tell me how comfortable you are with networks. You know, just say on a scale from 1 to 10, just so I kind of know where to teach at. With 1 being what's a network, and 10 being, you know, you wrote the first version of Cisco's iOS software. So if you could just give me that, and then I will go and teach accordingly. All right, a 6. Okay, good. All right. So, Mike, I think you're the only one. All right, Paul, you're in here too? Awesome, Paul. A 5. Okay. So I think we can bypass some of the things, and I could talk through some interesting things I went through today. So I've been involved in working on IP lighting and getting kind of the IP PoE lighting going. And one of the concepts that is real interesting with IoT and with IP is the concept of addressing and dynamic addressing. So you have concepts which are DHCP, which is Dynamic Host Configuration Protocol, which basically goes, and this device comes and says, hey, I need an IP. And then what happens is that goes to a server which says, oh, hey, here you go. Here's an IP you could have. And that device, oops, hold on here. That device then goes and says, oh, great, thanks. I'll take that. And then the lease information is sent out. And basically, a device is leased an IP address for an amount of time. Now, why am I teaching you this fairly basic concept of DHCP? It's because what I'm encountering as I work with this IoT and IP lighting is that no IT guy in his right mind wants to map static IP addresses to 1,000 or 10,000 light fixtures. I mean, imagine what a headache it would be. So they have a DHCP pool, right? And this is why I'm telling folks, I'm sounding the alarm now that if you're in the BAS space and you don't understand IT, you really need to get up to speed on it, because these things are coming. You know, IP lighting, IP building automation systems. It's all coming down the pipe, and if you don't understand how this stuff works, you're going to be in for a world of hurt. So you got this DHCP pool, and it goes, and this is my really ghetto rendition of a light here, but it goes and applies to some lights based on their MAC address. So what happens is there's this thing called the OSI model, okay? And the OSI model basically represents how networks communicate. And you've got layer 1, which is this physical layer. You've got layer 2, which is the data link layer. And then you've got layer 3, which is the network layer, right? Okay, and at the data link layer, we communicate via MAC address. The network layer, we communicate via IP addresses. So you all following me so far? Is this kind of right about the same level? You guys good so far? Give me a thumbs up. Let me know. And what's happening here is this MAC address is linked to, all right, good stuff. This MAC address is linked to what is called an ARP table, right? So ARP. It's not a noise a dog makes, but it is actually called the Address Resolution Protocol. And basically what happens is that layer 2, so as you're communicating messages, right? So as you have a frame, it gets encapsulated by a packet, and inside the frame you have the TCP UDP segment, and these messages basically get encapsulated. So what happens is now you've got this packet right here, right? And this packet is on what's called a local area network, and these devices can't interrogate it, so they have to use what's called this address resolution protocol, where they look at the MAC address and then resolve it to the IP address. Well, since there's no static IP addresses here, you can imagine that it can be a little difficult to go and know what light is what IP address. As I discovered today when I was working on things, trying to go and configure the lights directly, I'm so used to being able to enter the MAC address of a field controller and just go to it directly. But with IP lighting or IP controls, you're not really able to do that so easily. Everything has to go through the server, because the server is managing this address resolution protocol, DHCP pool, MAC address. So if you don't understand these concepts and you're trying to troubleshoot these lights and figure out why they're not communicating, and you don't know how to do an ARP table lookup, so that would be called ARP lookup, and you don't know how to look into a DHCP lease, then you're not going to understand how these things are working. So right now we've covered all this kind of at a high level. I'm going to clear this board and I'm going to go into it a little deeper with a scenario real quick. Oh, hold on. But before I do that, are there any questions on what I've laid out so far? Okay. Not seeing any questions. I'm going to move a little deeper now. Okay, so when you're planning out these fixtures, you've got to plan out for what is called a subnet. Because even if it's DHCP, you still have to have a pool of addresses. Now, how do you get a pool of addresses? Well, you have what is called subnetting. So in this case, we're going to call this set of 4 fixtures right here subnet A. And what you're doing is you're given an IP address range. So let's just say 192.168, and this is what's called a Class C address. 192.168.0-24. Does this look familiar to any of y'all? Does this look like something that you've seen during your BAS careers? And if so, where have you seen this? Where does this look familiar from? And I'll give folks a second. And it's okay if you guys don't know, that's fine, because we're going to talk through this. So if you're looking at this right here, where this comes from is, let's see. I got a comment here. Let's take a look. Yep, so you've seen it before. So what we're dealing with here, right here, is this right here is the network portion. Okay? And this is what's called the host portion. And this is a classical network setup that you'll see when you're working with IT folks. They have 3 levels of networks they can give you. They have the 10 dot whatever, the 172.32 if I remember correctly, and then the 192.168 dot whatever. And basically what these are Class A, Class B, Class C, and it's a late night. I could go and Google the actual for A, B, and C. I don't remember it off the top of my head though right now. But essentially what's going on is with a Class 24 network, what is going on is under any of these right here, 192.168.1.0, each one of these is 8 bits, right? So it could be a 1 or a 0. So 1 or a 0, 1 or a 0. So 1, 2, 3, 4. Yep, okay. And then each one of these adds up in binary to a value. So 1, 2, 4, 8, 16, 32, 64, 128. And then as these bit registers are set, you then add up these values and they become these values right here, right? Well, if you add all of these up, you have 255 potential addresses. Okay? But the thing is that the way networks work is you have to have one for your default gateway and one for your broadcast. Okay? And what that means is that whenever you do a subnet, it's n squared minus 2 for your hosts. So, or 2, nope, there we go, 2n. It's late at night. Let me see if I can erase this. Nope. Okay, well, I'll just draw down here. 2n minus 2 equals your hosts. Okay? And so why that becomes important is this /24 network. So that means that these 24 bits are network bits and these 8 bits are host bits. So 2 to the 8 is 256 minus 2. That means we have 254 hosts, which means if I got a 192.168.1 network and a .0 host, I could only put it on here. So what's going to happen here is now with all these light fixtures, the BAS guy needs to understand subnetting because he's going to have to go and work with the IT guy to get the right network. And basically this is called CIDR notation. He's going to have to get the right subnet that can handle the right amount of hosts. But here's the problem, and here's where we start to dive a little bit deeper. BACnet acts, right, with broadcast domains. And have you ever tried to do more than 254 devices on a BACnet broadcast? It starts to get really ugly. It starts to get really congested when you start to do that. And what do I mean by that? If you have more than 254 BACnet devices in a single physical network, it can get a little congested, especially with the older controllers. The newer ones, not so much, but the older ones, it can. And so if you're trying to do BACnet connections to all these fixtures, you can potentially run into an issue. But the bigger issue is that if you don't understand what we just covered in MAC addresses, and you don't understand what we just covered in the ARP table lookout and DHCP, then you're going to find yourself in a lot of hurt trying to, one, troubleshoot, but also to design these networks. All right, so that was a lot, and I've tried to balance talking not super high because we're going to have other folks that are going to look at stuff. but I also wanted to give you guys something that was of value as well. So with that being said, I'm going to shift now to the question and answer section, where I am going to answer any questions that come in. And now that I have a whiteboard here, I can actually whiteboard out, which, by the way, guys, give me your honest feedback. Is the whiteboard helpful? Is that helping? I'm still learning how to use it, but what are your thoughts? Awesome. Great. Yeah, I definitely like it. I like to be able to communicate that way. So what questions, what challenges have you guys encountered, and what would you guys like to know about? So thanks, Paul, and thanks, Lee. What last night with my private group, the folks who bought the book, we went through a pretty deep topic on IoT. But can I capture and download from it? Yes, I can. This is Paint. This is Microsoft Paint right here. So I can actually go and just save whatever I create. And actually, I can show you. Let me just switch here. It's just this thing right there. So you can see. It's called a Wacom Pro small thing. I'll put a link into the actual post here if you guys want to look at it. It's pretty nice. I like it. I think I'm going to start using it much more often. I'm going to get back into doing YouTube videos, and so I wanted to try this thing out. But what questions? I'm sure you guys have encountered something recently in your job site journeys. I had a call from someone today, and he was asking me how to properly estimate jobs. And I started to talk through that with him. And I started to talk through how when you're estimating jobs, it's important to have a checklist. It's important to think of, and I'm going to go back to my whiteboard here for a second. Let me transition over. It's important to think of a couple things. So the first thing you got to think of is whenever you're designing a quote, HVAC really breaks out into two things, right? Air and water systems. And inside the water systems, you really have hot water, chilled water, and then under the air, you really have VAV and constant air volume systems. You really have, and then, with VAVs, you can say, I've got air handlers, I've got, 100% outdoor air, I've got mixed air, etc. And with constant air volume, you can have dual duct boxes, single duct, makeup air units, etc. And then, with hot water, steam, and then multi-staged boiler plants. And so what I said to him is I said, list out these systems, right? So list out, for example, a HU. And then you say, all right, what kind of system is it? It's a VAV 100%, or not 100%. It's a VAV mixed air system, right? And so I said to him, all right, now that you know it's that, what do you need to know that you control? Well, you've got a supply fan. You've got a mixed air damper. You've got a return air damper. And an outdoor air damper. You potentially have a cooling valve. Most likely do. I would be shocked if you didn't. And you have a heating valve. You have discharge air, return air, mixed air temperatures, and then you have static pressure, so SP, or some folks will call it DP, discharge pressure set point. And you have a high and a low static. And you probably have a low temp alarm. So I said, all right, so you've listed this out. And now what you do is you go and you say, all right, you look at the job drawings. Does it show each one of these? You look at the specification. Does it show each one of these? If it doesn't and you have time, you submit what's called a request for information. And you say, hey, this is a mixed air VAV system. And I noticed that you don't have a VFD included. And you're like, I'm not quite sure how you're going to do a VAV system without a VFD. Can you clarify that for me? And so then what I told him is once you've clarified that, that becomes your design and your risk log. And then what you do here is you work with your technicians to start to understand, what does it take to do this? And you build out your block of hours. And you say, okay, based on these kind of points and this kind of system, it's going to be this many hours. It's going to be these materials. And then here are my risk factors. And with these three things, you should be able to develop an effective design and or quote. And you can gradually build out a library of all these systems. This is what I used to do back when I would design and quote jobs, is I would build out this library of systems. So what are your thoughts on that? What do you guys think? And then, what else? What else happened recently? I answered last time. Last time I went through and I discussed how we went and could address Fernando's question about how to tie in an older system with a newer system. So let's see, right here. What do I consider as risk factors? That is a great question. So let me go back to my whiteboard. All right, and I will list out those risk factors rather. And let's see here. Backnet bend. What do you mean? I'm not quite sure I understand the question. Let's see. Oh, BBMD? Yeah. Oh, did I? Okay. Yeah, that's a backnet broadcast management device. So basically, and I'll give you guys this link. Let me post this link real quick. Backnet IP tutorial. Let me grab this sucker for you guys. And I highly encourage you, if you haven't seen this yet, that you check this out. Which it's pretty old school, but it's a really nice description of how backnet IP works. So first let me answer the risk factor question, and then I'll go through and I'll answer the other questions. So you should be seeing my whiteboard right now. Let me make sure I transitioned over to that. All right, there we go. And here we go. All right, so the first question was risk factors, right? So at the end of the day, you're liable for what is in the contract and spec. But you are usually also liable for what's in the mechanical and the general and ultimately the design team. Because what happens is you often have what's called roll down contractual requirements. So that would be my first risk factor, would be fully understanding what you are liable for. The second thing I would say is a risk factor is whenever you have to tie into a third-party system. That's a risk factor. And another risk factor is going to be compressed timelines. And also, it's going to be high security and or low access locations. And what do I mean by high security? Prisons, low access hospitals, places where you're going to be having to do double time, or you're going to be doing time and a half, and you're constantly going to be interrupted. Those are all factors. Now, in addition to that, I will call them, I wanted to say another word, but we're just going to call them fancy sequences. So I had this engineer, and he designed a entirely wood music recording studio in Dallas, Texas, with a fan coil, with a cool chilled water valve, with no form of reheat, and 100% outdoor air. And his logic behind this was the hot, humid air would hit the cooling coil, which would dehumidify the air, and it would come out at the right level of humidity and 72 degrees. Now, if you know psychometrics, and you've seen a psychometric chart, right? And you know that the lower you move, the closer you get to, this is called saturation right here, where you can't have any more humidity in the air as you're moving this way. Well, what's happening is when you're already fully saturated, when you're at like 70% relative humidity outside, and then you move across, you're never even going to hit 55 degrees. You're going to hit like 68 degrees and be at 100% saturation. And then trying to get to the point where you're at 55 degrees, you're still going to have residual humidity because you're just not going to be able to wring that out. So fancy sequences are always my biggest risk factor. They're the things that really get me concerned. And then finally, obvious design failures. And what do I mean by that? Well, let's do a little scenario here. All right. Got my air handler. I've got my valve right here, right? There's my little valve. Okay. And I've got a damper. And then I've got my pressure sensor behind the fan. And I've seen this before. And electricians will put in whatever you tell them to put in. And so like a design drawing that has a pressure sensor behind the fan, or maybe a damper that does not include actuators in the damper schedule, or maybe a valve that is in no way going to be able to cool that coil. There's all sorts of factors. Or maybe you see something like this, right? You see a DX unit with 2 stages of cooling, and you see a fan with a VSD on it. And then you ask yourself, how exactly am I going to control stage DX cooling with a VSD unit? I've seen it done in the past using bypass dampers that would go and bypass, so that way you always had the right amount of air over the coil so it didn't freeze. But those are the kind of things I'm talking about. Those are the kind of things that are risk factors. Unfortunately, they're also the kind of things that you got to have a little bit of experience to pick up on. So I know I kind of went off on a tangent. Did that answer your question? And while you respond to me, I am going to go and talk about BBMDs. All right, so BACnet BBMD. BACnet Broadcast Management Device. All right, so you've got a subnet. Actually, subnet would be a bad. Let's call this a LAN. Local area network. And inside here, you've got your BACnet device, and it's got its field controllers. So we're going to call this supervisory. We're going to call this controller. And then this goes over here to a switch, right? And then this switch has maybe another supervisory device coming off of it and another controller. All in the same LAN, right? Everyone's happy. This supervisory device can simply connect to this supervisory device, just doing regular IP traffic. Everything's going to resolve. There's no gateway issues. However, now you've got building number 2, and you've got another switch, and it's got a supervisory device and a controller, and another supervisory device and a controller. And this switch is going to be connecting to a router. Okay? Now here's the problem. How does this broadcast, which broadcasts, if you remember from IT world, broadcasts get constrained or get kept within the local area network they're in. Broadcasts do not leak. Otherwise, you'd have a crazy amount of traffic going all over the network. So you need to have something that says, oh, you're looking for the devices on this network? Well, I know that they're over here, so you need to go and route to, maybe this is 192.168.2.1 or 2.0, and this is .1.0. X and X. Okay? And so the BBMD essentially equals a routing table. That's the simplest way to understand it. A BBMD is a routing table. So, hopefully that answers your question on BBMDs. Gives you kind of a better idea as to how they function and what they do. If you want to go even deeper, that link that I put will talk about how the table is built. It'll talk about the different virtual links that are created, because it's not as simple as creating a routing table. You've got to create a link. And so the BBMD will create a virtual link at the IP level. No, it's not manually entered. Actually, that is part of the BACnet process. So what happens with BACnet is it will go and send who is messages, and these who is messages will get sent. And then as BBMDs are set up, what will happen is you have to tell a device that it's a BBMD, but it will broadcast out messages to other BACnet areas, and it will find that. So hopefully that makes sense. If you go here to about, I think it's page, right here. This talks about the broadcasts. And so then what will happen, it talks about, here you go, how the BBMDs are configured. And then it talks about the architecture of how these messages are typed. And like I said, this goes fairly deep into the actual message structure. What I really like about this tutorial is it's building the BBMD network as you talk through the tutorial. So you'll see as you move through this, up here it's gradually being built, and you'll see it just grows with time. So I really like this one as a way of describing how this works. So there you have it. Let's switch back to the video over here and see if there are any more questions coming through. If not, we'll just wrap it up, and I will be here next week to talk through what we discussed or what I covered. Here's what you can expect in the next week. So I am going to be starting the system integration series on next Monday and be going through that. I'm also going to be recording 2 podcasts, and I'm going to be doing a Learn series on how to tune PID loops. So next week's teaching, we'll probably use most of the time to talk through how to tune PID loops. We'll talk through that, and then we'll also talk through any questions. As always, if you have questions, just post them in the group chat under the event, and that way I can address them. And we will talk through the system integration series and what you can expect on that. Because my plan is right now, based on a lot of the feedback I've gotten from folks, is to take the specification article I just wrote and turn that into like a kind of video book kind of thing that I've gotten from some engineers and some owners that would like to see that, along with a checklist. So I'm working on that. And then the system integration, that's going to be a full-blown series where I talk through, how do you go and look at systems, and how do you go, and it's going to follow what's called the TOGAF, and that's the Open Group Architecture Framework for Enterprise Architecture. And we're going to be following that methodology through, and it's just going to talk about how do you look at your architecture, specifically building automation systems, lighting, stuff like that. So, any questions on any of that? Hopefully it all makes sense. If you're watching the video after the fact and you comment, you will see that it will put a timestamp whenever you commented, so I will be able to know when you commented. And I will have this video also. Some of you will be viewing this on YouTube, and just leave comments there as well. All right, folks, if there's no more questions, I'll wait a couple minutes and then call it a night. I want to thank all of you for being here tonight, by the way. I appreciate it. Of course, man. Go ahead. You too, Paul. Take care. No problem, Mike. Look forward to seeing you. Do I generally encounter a BS manager in large facilities? I typically will encounter a facility director or someone who is a manager of the low voltage. That's what I will encounter. I don't typically encounter someone who is directly over BAS, except for in the higher ed space. In the higher ed space, I tend to find that they have a manager over the BAS group because they like to do a lot of self-execution. However, in the rest of the vertical markets, I tend to find it's in healthcare, in K through 12, those kind of things. It's a facility director or facility manager, and then they have technicians split into HVAC, low voltage, and BAS. And then when you get into commercial real estate, I tend to find that it's all over the map. You've got groups that are outsourced. You've got groups that are in-house. and I don't tend to find managers of BAS there. I tend to find managers of facility systems. So that's what I see usually. Yeah, you know, I think that what I have been seeing is the consolidation between IT and BAS. I've been seeing that IT is becoming much more heavily involved. BAS systems are now becoming part of the environment's technology roadmap rather than just being some obscure purchase. So I think IT standards are going to become more involved. And honestly, if I were a betting man, I would say that within the next 20 years, facility systems will probably fall under the technology and IT group. I just think it'll get to that point. And honestly, I think that folks will start mainly using service providers for the mechanical work, and they'll keep all the technology work in-house and just manage them as regular IT assets. And then you may actually see a whole new slew of companies that are taking kind of the managed service provider like Verizon and Dell and all them who do managed service providing, where they manage your IT assets for you. I would be shocked if we don't see that happen, where you've got managed service providers running BAS systems. And that would be a real interesting world. But I just don't see with the skill gap we're facing and the talent gap and just the body gap we're facing, how we can replenish fast enough. So who knows? I could be totally wet on that. Yeah. As I've found out, our IT group uses managed service providers as well. As I was trying to troubleshoot a switch the other day to get it to work in my lab environment, and I wasn't allowed to have access to the configuration in the switch, so that was kind of a nightmare. Trying to find interesting ways to make a configuration work without being able to change or know what the upstream switch's configuration was. So yeah, no worries, man. That's why you're in the group, right? I would ask the group. I would just go throw this out at the group and say, hey, group, what is your take on it? Because, you know, at the end of the day, I've worked on almost every BAS out there, and I've worked on a ton of projects. But there's a ton of projects I have not worked on. There's a ton of sites I haven't worked at. And I always am of the perspective that anyone who tells you they know everything, you should always question that. So, yeah, I encourage you guys. That's what I'm hoping to see from the group is, unfortunately, there's only so many hours in the day that I can work on this. And so if we really want to take this whole thing to the next level, gotta engage the group. I can focus on putting courses and articles together, but you know, that mind share that's in the group, that would be really important for us to have. So hopefully that answers your question. Anytime. All right, folks. Well, if there's no more questions, I'll wrap it up. Yep, take care. Good talking to you. Alrighty. Well, I'm going to call it a wrap. Thank you for everyone who attended. And this video will be up shortly. I encourage you to watch it, and I'll be putting it on the YouTube channel as well. Thanks. Take care. Have a good night.